So what if I asked you to do something easier than solve this? I don't care about the solutions. I just want to know what kind of numbers are we going to get. Describe the nature of the solutions of this quadratic equation. I mean, you'd probably just plug them into the quadratic formula, right, and see what you get. Okay, let's do that. Now, what I want you to do, though, while we're doing this, I want you to try to figure out a really efficient, clever strategy for doing the least amount of work possible. Okay, does that sound good on a Friday? So we're going to use our quadratic formula. Now we have z's instead of x's, but no, who cares? So let's warm up your singing voices and remind me what the quadratic formula is. Z equals... You're not even going to sing it? There you go. Okay. Good. Now I've heard better musical productions in my life, but I'll take it. So what are the values? That's true. Okay. So what are the values of A, B, and C that I'm going to plug in? 5, 7, 14. Okay. So let's see what happens here then. So I get negative B, which is 7, right? So negative 7 plus or minus the square root of 7 squared, that's 49, right? Minus 4 times 5, good. Keep going, times 5 times 14, okay. There we go. Okay, all divided by 2 times 5, so that's 10. Agreed? Can anybody tell me yet what kind of numbers we're going to get? We'll keep going. Let's do another step. Negative 7 plus or minus the square root of 49 minus 20 times 14 would be 280. So 49 minus 280 is going to, can anybody tell me what that is? 49 minus 280? 231. Okay, but 49 minus 280 would be negative 231, okay? Can anybody tell me now what kind of numbers are we going to get? We're getting imaginary. We don't have to go any further, right? Oh, I thought I heard somebody whispering that out there, but yeah, excellent, excellent. So we know we're getting imaginary. How come? Ah, okay. Because the number, here we go, this part, right? The number inside the square root, we didn't really even need anything else, right? The number underneath the square root was negative. And so because that was negative, we knew that we were getting 2 imaginary solutions. Done. Okay? Okay, let's try another one. Same question, different equation. Okay, now that one we got to do, we can't really use the quadratic formula yet. What do we have to do first? Okay, good. Move everything over to the left because we got to set it equal to 0. Good. So let's see if we do that. Oops. So that's going to give us the equation 2x squared plus 8x minus 7 equals 0, right? Okay, so now we'll plug into the quadratic formula again here. This time, you got to do a better job with the quadratic formula this time. Come on, people. Okay. X equals... That's much, much better. Okay. So if we plug in our values then, and our values agreed just 2, 8, and negative 7. Okay, so we're going to get negative 8 plus or minus the square root of 8 squared, that's just 64, right? Minus 2 times what? Times 2 times negative 7. Okay, all divided by 2 times 2 is 4. Good? Okay, now what's going to happen here? If I'm subtracting a negative, I'm going to get positive, right? So one thing we can do right away, if I'm subtracting a negative, I know those are just going to turn positive. Okay? So we end up then with negative 8 plus or minus the square root of 64. Now what are we going to get here? 2 times... Yeah, I think did I write something down wrong here? Oh, I forgot the 4. Yeah, no wonder. I was going to say something didn't look right there. Yeah, I forgot the 4. So we had to go back here. We were supposed to get 4. Oh, did I write it as a 2? Oh my goodness, why did I do that? I'm doing algebra about as well as I'm counting today. So minus 4 times A times C. So let's see, and those turn positive, we said. So 64 plus 8 times 7 is 56, right? 64 plus 56 is just 120. So inside the radical this time, I'm getting a positive 120. Can you tell me anything about the solutions yet? They're going to be real, aren't they? Because this time, if the number's positive inside the radical, I'm getting real. Oh, and by the way, how many am I getting? 2. How come 2? Plus or minus. So I'm getting 2 of those. Okay, so right away we know we're getting 2 real solutions. Let's keep going, though, and see if we can even say something more specific than that. I better go back in the notes. Oh, I guess I did write 2. Never mind. Okay, so if we keep going, let's make a factor tree out of 120. Okay, are there any perfect squares that divide into 120? Look at our list here. Don't think so? Well, if we work backwards, not 144.
I thought you meant like evenly.
Well, are there any?
Like 120 was a perfect.
Okay, it's not a perfect square, is it? You're right. But are there any that divide into it? 4 does, doesn't it? I don't think any of the other ones do. If they do, we'll catch them later, right, when we keep doing our factor tree. But if we break this thing up, I get 4 times 30. And that's 4 was it, right? Because no perfect squares divide into 30, agreed? 30 is just going to break up into a 6 and a 5, so a 2, a 3, and a 5, all singles, right? So we can just leave that one the way it is. But the 4 gives us a couple of 2s. So look what I'm getting here. A couple of 2s and a single 30, right? So when I write down my answer a little more simplified, I'm going to get negative 8 plus or minus. On the bottom, I've got a 4. What's the outside number that my square root of 120 gives me? 2. So I'm getting a 2 outside in my inside number. Okay, so can you tell me something about those? They're real solutions. But let's think back to the start of the year for a second. We talked about number sets, about the real number sets. And the 2 really big important ones were rational and irrational. All real numbers are either rational or irrational, right? Now, what did we say about rationals? Ratio means fraction. So rational numbers are numbers that can be written as fractions. Irrational numbers cannot, right? What about as decimals? Rational numbers can be written as decimals, and they always work out to be what? Like, think of examples, like 1/4 as a fraction is, or as a decimal is 0.25 terminates, right? So they either terminate, or if I do something like 1/3, what's that?
Either repeats or terminates.
Repeats or terminates, right? Okay, so rationals either repeat or terminate. Irrationals go on randomly forever. What were examples of irrationals? Pi, what else? Pi is the big one we always hit first, but there's a bunch of other ones we see all the time. Like, what about square roots that we're stuck with? Like square root of 2, irrational. Square root of 3, irrational, goes forever. Square root of 4? We're fine there. That's rational because 4 is a perfect square, right? But square root of 5, irrational. Square root of 6, irrational. Square root of 30? Irrational, right? As long as we're stuck with a square root of something after we simplify the radical, we know that we're going to get an irrational result then, right? So only when the square root is able to completely go away that we don't have irrationals, that we get rational answers. Okay, so in this case, we get two real irrational solutions. Okay, and why irrational? I'll just make a little note of this to remind you. We know they're irrational because I'm stuck with a square root, right? Okay, that's why we know they're irrational. Okay, give me thumbs. We good? Okay. Next one. Same question. Different equation. Okay, we can jump into this. Maybe we'll skip the formula. We'll just plug in directly this time. So x equals negative b. So what's that going to be? Negative 5 plus or minus the square root of 5 squared, so 25, minus 4 times 1. Okay, all over 2a, so that's 2 times 4, so 8. Okay, so that's giving me negative 5 plus or minus the square root of 25 minus 16, 9. Oops. What's the square root of 9? 3. So I get back negative 5 plus or minus 3 divided by 8. So if I went further, if I take the plus sign, I get x equals negative 5 plus 3 is negative 2 over 8. Okay, if I take the minus sign, I get x equals negative 5 minus 3. Yeah, good. Negative 8 over 8, which is negative 1. So what kinds of solutions are those? Those are rational, aren't they? Right? How come? The square root went away because it was a perfect square number inside the square root, right? So our results are 2 real rational solutions. And how come? No square root. Okay? Give me thumbs. Okay, last example. Same kind of thing. What about this one? So x equals negative b. What's that going to be? 24 plus or minus the square root of negative 24 squared, that's 576, minus 4 times 1 times, okay, all divided by 2 times 1 is 2. So let's see, if I multiply something by 4, there's a great little trick. Multiplying by 4, you're just doubling it and then redoubling it, right, to get 4. So 144 doubled is 288. 288 doubled is 576. Okay? So look, I'm getting 576 minus 576. I'm getting a 0 inside the square root. Well, what's 24 plus or minus the square root of 0? Well, the square root of 0 is 0, right? So what's 24 plus or minus 0? 24. 24 divided by 2 is, we got one answer, right? So that's different. This time, instead of getting 2 real solutions, we're going to get 1 real solution. Now, is it rational or irrational? It's rational because the square root did go away, didn't it? Square root of 0 is 0. So no square roots. So we get two real, or one real rational solution, not two. And again, how come? No square root. So that's why it's rational. So we could summarize all this stuff. So what's this all about? We're just trying to establish some patterns. Well, first of all, we did way too much work on those. We didn't even really have to write out the whole quadratic formula, did we? What's the only part that ever really mattered? The top, but which part of the top part? Yeah, the part inside the radical, right? That's the only part that ever really made any difference, right? So that's the part that discriminated for us between the different types of solutions. So we call that the discriminant because it helps us discriminate. And discriminate isn't always a bad word. Discriminate means to select or choose or separate too. I mean, you don't always have to use it in the context that we usually use it in. In math, to discriminate between solutions means you're just going to separate so you can tell which one goes where. We're going to group them, right? So this helps us discriminate between the solutions, types of different answers we could get. We call it the discriminant. Let's summarize what happened. If the discriminant, the b squared minus 4ac, part inside the radical, was negative, what was the outcome? If the discriminant was negative, the discriminant is the part inside the square root. What did I get? If the number under the square root is negative, think about that now. If I get a negative number inside the square root, what's that giving me? Okay, that's giving me imaginary solutions, right? So when the discriminant's negative, we know we're getting two imaginary solutions. End of story. Okay? What happened if the discriminant was positive? I got real solutions. I got two of them, right? Okay, now we can go further than that, though. What if the discriminant, okay, yeah, it was real, but what if it was a perfect square? They were real, but what else could you tell me? If the discriminant was a perfect square, they were rational, weren't they? Right? Because the square root of a perfect square goes away, right? I don't have any square root left over. So that gave us rational solutions. What if the discriminant was real, but it was not a perfect square? Irrational. Okay, and then finally, what if the discriminant was exactly equal to 0? What happened then? Real. How many did I get that time? I only got one. Good. Only got one solution. It was real. And was it rational or irrational? It was rational. Okay, so let's fill out your notes. Try this on your own. First of all, just see if you can remember what's the formula for the discriminant. We call it D, and you already know it. You already know this formula because you know the quadratic formula. What is it? B squared minus 4ac. Just the part that's inside the square root in the quadratic formula. So if the discriminant is positive, how many solutions? Roots just mean solutions. How many solutions did we get if it was positive? 2. Okay. If it was a perfect square, positive number, what kind of solutions were they? Rational. So they were real, rational solutions. If it was a positive, non-perfect square, we got real, irrational. If the discriminant was exactly equal to 0, we got 1, real and rational. And then finally, if the discriminant was negative, we got 2. What kind? Imaginary. And we could either call them imaginary or non-real. Same thing. The questions you get on the assignment might say either one. Okay? All right, so now if we go back, these are the actual kinds of questions you're going to see. So the first one we did, where we got a discriminant of negative 231, we did way more work than we actually needed to. This is the way the question is going to be phrased. They want to know what's the value of the discriminant. Okay, well, we already calculated that. It was negative 231. So then you tell me, vote with your fingers here. 1 is A, 2 is B, etc. Take a second and think about that and cast your vote. What's the best way to describe that, the solutions we're going to get from that quadratic equation? Good. Okay, good, good. Okay, I'm seeing lots of the correct answers. Seeing lots of 2s. How come 2? Riley, how come?
Well, it's a negative, so it's going to be not real.
Yeah, good. I know I'm going to get I's because I have a negative number under the square root. So negative discriminant tells us 2 non-real answers. So the part that gives this away is right there, right? Not real. Okay. Next one we did. Well, we got a discriminant of 120 this time, the number under the radical. So if the discriminant's 120, again, cast your vote with your fingers. Think about it for a second. Let me know what you think. Okay, back to the drawing board, Brock. Try it again. 120. No. Not 2. Not 2. What's it going to be? Yeah, how come? You're right.
I got it right.
You did. How come?
Because it's not a perfect square.
There you go. It's positive, so it's real, but 120 is not a perfect square. No number squared is equal to 120, right? So we know we're going to get stuck with the square root. Good job. So it's going to be irrational, right? Okay. How we doing? Give me thumbs. Are we getting this? Okay. All right, let's try it. Now, what about the other next one we did? So this time we got an answer of 9 under the square root. Okay, if I get a discriminant that's 9, again, vote with your fingers here. Good. Good, I'm seeing lots of them. Good. Okay. Good. Austin, you're right. How come?
I'm not 100% sure, honestly.
Okay, intuition. Your intuition served you well here.
Yep.
What do you think, Clayson?
It has, so it's greater than 0.
Mm-hmm.
And it has two real rationals.
Okay, yeah, we know the real. How come they're rational? What about 9 tells us? It's a perfect square. There you go. Right, perfect square. 9 is equal to 3 squared. In other words, the square root of 9 is 3. No square roots. Okay, good. So we know this time we've got 2 distinct rational real solutions. And again, remember what happened if we just look at the math we did. Look, we got answers that were just fractions. In that last one, maybe I should have pulled this thing down, right, where we got 120. look what happened in our answer. We ended up getting answers where we got stuck with a square root because we started off with a number that wasn't a perfect square. So because we got stuck with that square root, we know they're irrational. Okay? Last one was that guy where we got 0 for our discriminant. Okay, so, oops, that's not the one I want. I think I gotta go. There we go. We got 0 for our discriminant. Okay, what did that mean? Vote with your fingers again. 1, 2, 3, or 4. Okay, good. Good. Okay, good. Gabby, what'd you get? Okay, how come? You're right. How come? Because what? Your intuition told you?
Yeah.
Okay, what about that? If I get a square root, the number under the square root is 0, what happens? I only get one number, right? Because both the plus and the minus give me the same result that time. So I'm only getting 1. And again, if we look back at the work we did, what happened there? I got 24 plus or minus the square root of 0, which is just 24, right? Only get one result that time, okay? All right, last one. This is a very short one, and then we're done. And then I'll give you guys work day on Monday to work on this assignment. So what about this here? Like, what if we were given a quadratic function, and we want to know how many x-intercepts does it have? Okay, this is a really simple question if you remember 2 important facts. One of them is that only the real only the real zeros of a function. What do we mean by zeros? The zeros of a function are the values when the function is set equal to 0. They're the values that make the function equal to 0, right? Well, it turns out, I mean, what is an x-intercept? An x-intercept is what we get on a graph when what variable is equal to 0? Y, right? So x-intercepts always happen when y equals 0, which is what we're doing here. If I set this function equal to 0, aren't we just setting y equal to 0? Right? Now, when are we going to get x-intercepts? Well, we're going to get x-intercepts only when we get real x values from this equation that we could graph on an xy plane. If I get imaginary solutions, how am I going to graph that, right? When y is 0, if I got something like x equals 2 plus I and 2 minus I, how are you going to graph those on the x-axis? You can't, right? And so we only get x-intercepts from real zeros. So really, this is just a discriminant question, isn't it? In order for us to have 2 x-intercepts, what would have to be true for the discriminant? You have to be, right, it'd have to be real, wouldn't it? Does that make sense? Because then I'm going to get 2 real answers for my equation, right? What would have to happen for me to have only 1 x-intercept? Discriminant would equal 0, because then I'm only going to get 1 real solution. And how could I get a situation where I get no x-intercepts? The discriminant is imaginary. Well, it's negative, right? Which gives me imaginary results. What would that look like on a graph? Well, that's easy. It would just look like a parabola that does something like that, where it never crosses the x-axis. Okay? That's an example of a function that has imaginary x-intercepts. Right? They're not real numbers. So all we'd have to do is calculate this, which is easy for us to do. And we don't even need to know what the value of the discriminant is. We just need to know what the sign is. Is it positive or negative or 0? We don't even have to be specific. So when we calculate the discriminant, b squared minus 4ac, what's that going to give us? 6 squared minus 4 times 3 times 4. Okay, the way I see that is 36 minus some big number, right? See what I'm saying? 48's, I mean, it's bigger than 36 though, isn't it? Right? So is it going to be positive or negative? It's going to be negative, right? I don't even care what it is. I just know that it's negative. So what's that telling me? How many x-intercepts am I going to have? If the discriminant is negative, I'm going to have 0. Yep. Okay, give me 1 to 5. How are we doing? Okay, getting there? Okay, good. You don't have much time. You can work. I get the assignments up. Monday you can have a work day.